Now, good afternoon, everyone. Just see if you all of you have arrived, and start the lesson now. Yeah, perfect. All of you have arrived. Okay, so we will start the lesson right away. Now, I find quite a number of you feel not so comfortable while you talk about this topic, because we have to deal with lots of factual information, the equations. Okay, so today we focus on doing some more consolidation work before we proceed to chapter 15, because for chapter 15 it is something more about mathematics, the use of indicator, or something about the explanation that follows. So we start from question 14 and 15. First of all, do the balance the equation first. Okay, to have a warm up. Page 40. Page 40. Page 40. Question 14 to 15. So I would like to check your understanding first of all. Do you understand? Okay, I find many of you just give me about 4 to 6 marks only for your understanding yesterday. And I know that some of you who were just absent, sorry to say you that you have to read, you have to watch the videos. Just a few of you, you have to make sure that you have watched it. Okay, do you find it? First question is about reactions of acids, and the other one is mainly for base. Okay, 14 A, B, C, D. So in order to speed up the whole process, I would like to invite some of you, right? You have got, do you have a pen? Do you have a pen? Or you just simply use the function or to type the word here? Okay, to show me your answers. It is for 14A, B, C, and D. 14A, 14B, 14C, and 14D. Okay, just show me answers there. Now, first of all, I look for what? Observation and equations. Observation and equations. Well, the equations, you need to write the chemical equations. Okay, anyone who can help? Now do it now. Question 14A. Wang Yalong, do you have a pen? Or you may type it, or you may type it on chat box, or if you can type it in chat box, which means you may use the function. You may use the function word. Okay, we've got the T here, and you type it. Who else? Who else have got a pen? And yep, thank you. Lei Ching, do you have it? You may try one of them. C or D. And Deng Hao Jun, do you have a pen? I can't one. You can't write. So philosophical that you just write that I can't write here.
電話個 screen 寫唔到字啊，寫到咁樣。
Yep, you may type. You may type. You are using the mobile phone or what?
Yes, yes.
Mobile phone. Oh, quite hard. And you may tell me the observations and let somebody write on C part. What do you think? Solid magnesium carbonate is added to a dilute hydrochloric acid. Now I'm your secretary. Tell me. Yeah, something is missing. So, Lei Ching, do you have a idea for C part?
Is it a hydrochloric acid?
Yes, solid magnesium carbonate is added to dilute hydrochloric acid. Magnesium carbonate reacts with hydrochloric acid. So the observation. How about observation for A part?
I think it's a magnesium carbonate 加 HCl it turns to magnesium chloride and hydrogen carbonate 啊，唔好肯定。
Magnesium. So what will the product? Magnesium. You say that again.
Chloride.
Magnesium chloride. Okay, and
hydrogen carbonate.
Hydrogen carbonate. Hydrogen carbonate. So it depends on the amount of the acid, right, added to it. I must tell. Now, if you say it in a more advanced answer, I must tell, because it depends on how much acid is added. If you have added enough acid and such as to react all magnesium carbonate, the answer is very simple. It's salt, water, and carbon dioxide. However, if you want to talk about it as a half, I just add just 1 mole of hydrochloric acid to it. So what will happen to the product? So there may be a chance of having a something like hydrogen carbonate. There is a case while you may have got hydrogen carbonate, but also we have got some chloride salt as well. But it is a little bit complicated for the time being to digest. You focus on the complete reaction first of all. So this is what you may know. Now, how would you deduce the answer? You can check your chemicals. It is magnesium for the cation. You know the salt will form, right? So you choose half DNA from the MgHCO3 and half DNA from the HCl. Half and a half, you turn it, that is you, right? The baby, that is you. So it is magnesium chloride as the salt. Can you get a point? It seems like half of the DNA come from that and half of them come from what? It seems like this. And remaining is on carbonate. We added hydrogen ions to form carbon dioxide and water. Can you get a point? Okay, so we usually use this type of thinking model to help you write down the equations. Okay, so the observation is, yes, that's right. Many of you would, I see some of you have marked it here. It is the effervescence, EFFERVECENCE, or colorless gas bubbles, or you may say that the solid dissolves. The solid dissolves, and that is also the possible answer, right? The solid dissolves. Because we may find the product, the reactant, we've got solid, and then for the solution, it's just AQ. So of course, the starting point is the solid. The solid is dissolved, while the colorless gas bubbles form above the surface of the solid. Okay, the carbonate. So similar case for D part, but there are no solid here because two of them, they are in solution. Okay, so you may only tell the observation here, colorless gas bubbles, they are formed. Can you get a point? So what you may find today here is on the salt form. Okay? Where are the answer? Skipped. Suddenly disappeared. Yeah, thank you. So you may see that the cation here, right? The father, the mother, half of father, part of mother, here comes the son. So go back to the question. Potassium carbonate solid. And leaving behind is on the carbonate react with hydrogen ions to form carbon dioxide and water. Can you get it? So K2CO3 H2SO4, K2SO4 CO2 H2O, C and D, they are more or less the same. 差唔多呀嘛. How about A part? A part, I put a piece of metal into the exit. So you use the similar logic. You may tell the salt form, it is the metal part and the non-metal part, they form a salt. Okay, so leaving behind is the hydrogen ion to form hydrogen gas. Can you get the logic? Okay, so you may say that there are the colorless gas bubbles that are given out. Not just one, so many, right? Or you say that the metal, the solid, dissolves. Can you get a point? How about B part? For the B part, you may find it as a solid. Copper 2 oxide is added to dilute sulfuric acid. So the color of the solution changes from colorless to blue. Yep. Why? Because originally the acid is colorless, and while the product we have got copper 2 ion, which makes the solution blue. So this is possible. Of course, you may say that the copper 2 oxide dissolves in the acid. This is also a possible answer for observation. Now, if you write down the equation, you may use the similar logic, like copper 2 and sulfate, that is the salt. Okay, and leaving behind is on the oxide ion, hydrogen ions to form water. Would it be better? Do you understand? Now you may now capture the screen if you want to read it in detail, or you may watch the YouTube for the replay. Is that clear? So you go to question 15. Similar case. While this time we look for the expected observation ionic equation. Remember, you check for ionic equation for the following 1, 2, 3, 4, 5. I have 5 questions here. Observations, ionic equations. Okay, 1, 2, 3. So again, I invite the students here to continue doing this part. For 5 parts here, right? 15 A, B, C, D, E. Now it's time to write. Jae Hongming, do you have a pen? I just choose one question to answer. Ronald Lam, do you have it?
I don't have a pen.
Oh, it doesn't matter. So you may do it on in your book first of all. And yeah, you may read aloud the answer as well. Choose which part? Which part would you like to have a try on that?
Question
A, B, C, D, E.
C.
Yep, C. Now if you have the answer in mind, we may read it aloud and I can write for you.
Okay.
Oh, you have a pen. C part, right? That's C part. C part for you. Now, well, you know what's going on now?
I have no answer.
Oh, yeah. Yes?
NH4 plus ammonium ion, NH4 plus.
NH4+. Yeah.
And then OH minus.
Yep, OH minus.
And then there's like an arrow to the right.
Yeah.
Heat up on heat.
Heat above it. Yeah.
Ammonia NH3.
Yeah.
And H2O water.
Yep. Thank you. So the observation. Do you know the observation?
Colorless gas is given off.
Colorless gas is given off. What else? Now, for this case, somebody would think a colorless gas is given off, but the gas is highly soluble in water, so you may not so easily see anything like effervescence, right? Because you have got the two solution and warm it, while the gas is highly water soluble, so you never see any colorless gas bubbles. So which means that there are some vapor that coming out, but it is colorless. You cannot have a confined region to tell it is a colorless gas. Can you get a point? So step back to another observation. Instead of seeing, you may think of smelling, for example. What is the smell of ammonia? Can anyone describe the smell of ammonia? How would you describe it? Smell like urine, right? But you'll be quite I cannot tell you it's not correct, but it's not the way we mentioned in chemistry. We would describe the gas. But yes, very good. Pungent. We'll describe the gas as pungent. Pungent gas is therefore is formed. So you know that pungent, which means that it is quite difficult. You find it not easy to breathe in. Very nasty smell. So we call it pungent. pungent gas is formed. How about E part? E part, anyone who can help? Now this is for C part, okay? How about E? And Tam Wan, do you have a pen? Tam Wan Yao. Or anybody who can help for E part? Wang Xinghin. For E part. Now, C part is just we finished. You may go to some other parts. Let's start with B, because B has finished. For B, a white precipitate is formed while it dissolves to give a colorless solution. Now, take a look on this. Tam Guan, you have to solve the problem. You say that the mic is not functioning, but you may, yes, that's right, you can type. The white precipitate forms and dissolve. So whether or not there is a white PBT, right? So philosophical, you tell me that there are something not soluble, but all in a sudden is soluble. For B part, it's quite interesting. Something about English, you have to give more details. So this is the number 1 and number 2. Now I try to pick this one as an example. Now, number 1, a white PPT is formed. Okay, you are going to mention the condition. The condition is what? What solution are there? Sodium hydroxide, right? When sodium hydroxide is added dropwise. Can you get the point? So this is the key. This is what I would like to draw attention to it. So the white PPT itself will not dissolve in the color solution. It's conditional. It's conditional. So the conditions that will come when the PPT I put it into excess. Okay, when the excess sodium hydroxide is added, the PPT it will dissolve to give a colorless solution. Can you get a point? Only by having this, you will score that mark. While for the equations, yes, that's right. You may find it as, first of all, is aluminium ion react with hydroxide to form the PPT. That is the aluminium hydroxide. While the colorless solution is due to the formation of complex aluminate. Okay, while this happens when I add excess alkyne, excess NaOH into it. So remember, there's just NaOH or KOH that will make the aluminum hydroxide redissolves. Is that clear for B part? Do you understand? What should we do while you write that observation? You need to write it as detailed as possible. Now, otherwise, it will give you, the answer is too simplified. Just like this, you may give some confusion to the reader. How come something not soluble starts to be soluble? Can you get my point? Now, you check for D part. D, I see that D is something we're finished. the situation, the dilute aqueous ammonia is added to capital sulfate solution until in excess. Okay, so you have got the point, right? You have got ammonia is added dropwise. So here comes the formation of pale blue PPT. That is point number one. It matches with this number one. Copper 2 react with hydroxide to form copper 2 hydroxide. But if you want to look for more perfect answer, you may need to add ammonia. How come it will produce hydroxide here? How? You have to tell. How? So you need to write a reversible sign here. Ammonia react with water to form what? Hydroxide and ammonium ion. So we will call that ionization. Ionization reaction. Can you get a point? So here comes this one. And the second part is on the used to describe this one. How they will form a precipitate and we dissolve in excess ammonia to give the deep blue solution. Yes, that's right. So perfect for D part. That is correct. Questions? Now, how about E part? You write down as no precipitate are seen. Which means that at the very first moment, while I add one drop of ammonia to zinc sulfate, no PPT, or you just tell me the final result. Who just answer E part?
Hello.
Yeah. Why you say that no PPT? That is the final answer, right?
Because they are actually the white precipitates that are formed. They dissolve in the solution.
When would they dissolve?
When on the addition of excess aqueous ammonia is added in excess, so the precipitate.
Yeah. So when you present this answer, the format of answering this is similar to D part. Can you get a point? It's very similar to D part, but the observation is a little bit different. First of all, for number one, we have got the two-stage observation. Number one, we have got the white PPT. So the condition is NaOH is added dropwise. And condition number two, the white PPT, they will dissolve. To form a solution, what is the color of the solution? This is colorless. Now, if you don't know the color of the solution, don't worry, you just write the equations and try to see if it gives you a clue. So this is the not NaOH, it's ammonia. Why do I say it right like this? It's ammonia. Ammonia is solution is added dropwise. So the second case is ammonia solution. It is added in excess. So can you see the word until in excess? So until, which means I will record the whole stage of the addition and try to give you as detailed observation as possible, but not just tell me the final observation. Do you understand? Once again, you understand what is that? So the way to present the answer will be ammonia react with water ionization to form ammonium ion and hydroxide ion. While you have got the hydroxide ion, and they would react with zinc ions to form zinc hydroxide. Okay, can you get the point? It tells you the stage number one. Whilst the stage number two, it is zinc hydroxide solid to react with 4 ammonia to form the complex. It is tetramine zinc ions and 2 hydroxide ions. So you may see that they are quite similar as D part, very similar. It seems like a change of the ions, right, from copper 2 to zinc. What that there's a slight twist on the observation, because for the color of PPT is different. Okay, for copper 2 hydroxide is pale blue, while the zinc hydroxide is white PPT. Second is about the final solution, which tells you the complex when I add ammonia in excess. For copper 2, the solution is deep blue, while for zinc, the solution is colorless. Exactly, it's E part. Do you understand? How about A? How about A? I just see what Wanyana has been trying the best to write down. It is the water is added to the solid mixture of citric acid and sodium hydrogen carbonate. Okay, so the answer is first of all, there is a colorless gas bubbles that come out. Yet the equations. So it is solid. Mixture of citric acid and sodium hydrogen carbonate. So you may write down in 2 ways. First of all, you may treat the most simple one. You may treat the acid and the hydroxide dissolved in water, and you may get that equation. It is okay. It is somewhat simple, but you may, if you step back to the solid state of sodium hydrogen carbonate, it is NaHCO3 solid plus hydrogen ion to form sodium ion carbon dioxide water. So somebody would also write like this way. It is gas and water. Okay, so of course, this one is not hydride, it's hydrogen ion. And some more people would think that Mr. Chin, citric acid is a weak acid. Theoretically, it is not so possible to write a hydrogen ions directly because it's the weak acid. So if that is the case, you need to show the all chemicals there. Now it really depends on how you judge the whole thing. So in your cert level or in some DSC level, that answer may be accepted. Now the directly writing of a hydrogen ion to represent the citric acid inside is also possible. Okay, you get the point. Now, unless we have got one scenario, if the citric acid, the formula of it is not given, that is the allowed situation, right? If the citric acid, the formula of it is not given, they will just give you HA as a form, as a common form. Very often they will show citric acid is a tribasic acid. They will give you a form H3A and use this to write down the equation. You have to step back to this. But rarely they will ask you to write down C6H8O7, okay? Because the situation will be that you need to memorize the whole formula. And it's not so necessary to in your DSE. Can you get a point? In DSE or in cert level, if you read the past paper, you can get what I mean. And what is the daily application of this? Do you know? The water is added to the solid mixture of citric acid and sodium hydroxide. Sodium hydrogen carbonate. So what is that in daily life situation? You know it? You don't know it? 有冇人知啊？其實 A part 呢一個 case 喺日常生活中喺邊度出現㗎 ？A part 呢個 case， 嗱俾你 cap 咗先呢個，有冇人知啊？Wallace 啊，
嗰啲維他命 C 嗰啲啊，
係啊，康蓋斯維多斯入邊咧就係咁啦。咁原本咧你個粒 tablet 入邊有啲乜嘢嘅咧？嗱 ，we mainly get vitamin C。嗱 ，vitamin C is ascorbic acid。Now, in this, not just ascorbic acid, we have got citric acid solid. We have got sodium hydrogen carbonate inside. You bind it into a tablet. Okay, so in order to have a good mouthfeel, the manufacturer will treat that fizzy tablet like soft drink. Can you get a point? So they bind together and ask people to put it directly in the water and make it make it fizz. We call it fizzy tablet. You may see the word here, fizzy tablet. And then they would ask them to drink it like soft drink. And most of the time, you will see the fizzy tablet. They will be mainly having two flavors. What are the two flavors? Mainly, it's orange or lemon. You will never have a fizzy tablet which is of watermelon or banana smell. Do you know why? Well, do you know why? Why we will have a fizzy tablet having only the boring flavor, orange or lemon? 考下大家先，知唔知㗎？嗰啲以羅果子鹽啊、維多斯、康蓋斯呢一紮嘅呢放去炸一聲嗰啲咁嘅丸咧，全場呢啲飲品呢啲味咧嚟嚟去得呢兩隻味嘅啫，一隻橙味，一檸檬味，冇西瓜味，冇香蕉味，冇其他味嘅喎，知唔知㗎？知唔知點解？
係咪因為係橙同檸檬先有 citric acid？
橙同檸檬有 citric acid，仲有冇啊？咩意思啊？就係嗱，即係話咧，嗱 citric acid 咧原來有少少味嘅，嗱你明唔明啊 ？citric acid 嗰啲味係咩咧？就似檸檬味同橙味，所以咧佢係 manufacture from the manufacturer viewpoint, while they try to give some advertising for this work, they try to sell it as a lemon flavor or orange flavor. Instead of adding extra flavor to it, why not I sell it as orange or yellow flavor? In order to make it happen, very often they will do something to make it similarly more true, like drinking orange soft drinks or lemon soft drinks. How? They try to add some food coloring. They try to add some orange dye, okay, the edible dye to it. So you may, once you drink it, you look at it, you smell it, you taste it, it seems like orange. I tell you, it's an orange flavor. Can you get a point? Gentlemen, can you get what I mean?
Kind of。
你唔知我講咩？知我講咩啊？你用中文講一次，頭先我講咩？
唔係好明咯，我就係少少唔明成個 concept。
你講一次我聽，你講一次，我先講咩？
啱咪講翻 kind of 咯，所以因為完全係聽唔明一開始。
咁你知唔知我而家講緊咩啊？
個 fizzy table
係啦 ，fizzy tablet 啦，我哋講緊嘅康蓋斯、以羅果子鹽，即係所有呢啲咁樣嘅牌子嘅 chemical 咧，佢個運作原理，首先講運作原理先啦。運作原理係點㗎？原來入邊係含有一隻固體嘅酸 ，it contains one solid acid and some powdered sodium hydrogen carbonate. Before you put it into water, of course no reaction. 點解唔放落水就冇反應嘅 ？Cyrus, you know it? 點解唔放落水就冇反應嘅？
咪有層喺上面俾佢 react。
No reaction. Why there is no reaction?
可能
因為啲
蝕
acid 未轉咗 AQ 啊嘛，就唔得咯。
係啊，點解要一定要 AQ 先得啊？我問翻你啦。
因為 acid 嘅 property 一定要係 AQ 先有，咁嘅 solid 嘅係冇 acid 嘅 property
咁點
嘅嘛。
樣叫 AQ 啊？What should be added？
係因為有 hydrogen ion。
講得再仔細少少。Without what?
acid 個
With water, what will happen？
喺AQ 嘅 hydrogen ion 度先至出嚟嘅咯。咁所以
係啦，咩叫出嚟啊？我哋可唔可以執翻啲字眼先？
佢要 ionization 啊嘛 ，ionization。
Without water, citric acid, the solid citric acid will not be ionized to form what? Now, you let's have somebody else type it on the chat box, okay? Without water, what happened? Well, without water, citric acid, okay, does not dissolve and ionize to form hydrogen ion, okay, and thus doesn't have any acidic property. So which means that no reaction. That means no reaction. You get a point. No reaction with between the acid and the solid sodium hydrogen carbonate in solid state. You understand? How about when in water? When dissolved in water, what will happen? You use the same logic, right? Citric acid, they would ionize to give hydrogen ion, which exhibits acidic property. So how will you show that is a type of acidic property? By reacting with sodium hydrogen carbonate to give CO2 and okay, can you get a point? 明唔明？所以第一樣嘢咧就係 you know the chemical component inside the fizzy tablet. You know it. This is in solid citric acid and solid sodium hydrogen carbonate. You start from this. Can you get a point? Second question is about why it is always in lemon or in orange flavor. Can you get a point? So why? Because citric acid, the taste, the smell, taste or smell of citric acid in water seems like a lemon or orange. Okay? Can you get a point? While the citric acid, it is why will they smell it in common? Because it is commonly found in some citrus fruit. Citrus fruit, do you know what is meant by citrus fruit? For example, lemon, orange, or grapefruit. Okay, also they are of the example like this. Grapefruit is not 提子，係西柚啊。唔係我驚大家搞錯。It's not grapes, it's grapefruits. 西柚。咁啊，檸檬橙西柚其實佢有陣味咧係好類似嘅，咁係因為有 citric acid 作怪啦，明唔明？所以佢唔會有其他味㗎。咁啊，睇下你大個仔會唔會改下啲味啦，唔好檸檬唔好橙咯，就淨變西柚味咯，係咪啊？咁加咗橙色，咁你咪話橙汁咯。你有冇留意到啊？就係咁啦。OK？Is that clear？ 清楚未 ？Cyrus 明唔明我講咩？知唔知我乜？唔好再答我 kind of 殺咗你啊！明啊？好，咁啊，仲有少少時間啊，10分鐘。咁啊，你望一望後邊啲題目，有邊啲題目你想做嘅？呢啲應該識啦嘛？定係想？但係有3種類型啊，我琴日有講過少少，就係講緊酸同埋鹼一啲反應啦，第一種啦。第二種咧就係喺實驗上面點做嘅，實驗上面咧嗰啲嘅 set up，所以咧有啲 set up 咧就話要攞啲 gas 啊 dry 啲 gas 啊咁樣啦，係咪好多啦？咁第3種咧難啲咧係咩咧？就係測試下嗰啲嘅 unknown chemical 啦 ，distinguish 嗰啲啦。OK， 咁我哋做23啦。嗱，呢啲應該簡單啲嘅，因為我哋頭先講晒大部分嘅嘢啦。譬如呢啲，嗱，逼大家要咩㗎啦？嗱，我俾少少時間你咧，要整理下啲 notes 啊。完咗呢一課之後，即係要你話俾我聽啊 ，cat line 又點樣試到啊 ，n line 又點樣試到啊？嗰個 notes 咧，我上次有冇叫大家寫㗎？有嘛？
有啊，琴日有講。
係啊，開始好咯。我俾少時間你準備好冇？咁我要當功課收，我要睇睇。咁啊，冇 perfect 嘅答案啊，個答案唔一樣，但係你要 start to have， 你要有呢個 notes 啊。得唔得？23，睇下先未做。For each of the following pairs of substances, suggest a test to distinguish one substance. Distinguish 分辨啊。琴日講咗噶啦，就同 identify 唔一樣啊。呢個就叫做辨認。Which one is of a higher level of requirement is identification, right? But for distinguish, it seems like all one out. I pick up one distinctive features to tell the difference. I use it as a start, and you can tell which is which. But for identify, I need to know the true identity, the real nature of the chemical. You see the difference between the two terms. So you are going to suggest a test to distinguish one substance from the other and state the expected observations. Is that clear? So we have got calcium chloride, zinc chloride, solar sodium chloride, solar sodium carbonate, and iron 2 sulfate, iron 3 sulfate. We have got the 3. Okay, so here comes that. 考下大家先知道。嗱，係時候要學下呢啲 unknown 嗰啲啦，好好玩嘅。我話聽呢個，因為你要個 condition 咧玩得好咧，或者你覺得好玩咧，首要條件係要背晒嗰啲 equation 先嘅。如果唔係咧，你就好慘啦，喺度抄啦，抄資料啦，抄抄懵啦。OK， 好，揾下咩同學仔做先㗎嘛？秦學家 A part。羅康力 B part， 哦，李澤星寫嘅 A 啦，唔緊要啊，唔緊要啊。咁啊，長學家做 C 啊。嗱，好多方法嘅，話俾你聽，唔係淨係得一個答案㗎，有好多方法嘅。好，羅康力喺咪度？
喺度。
你用筆啊？
嚇？
用筆啊，一係就 type 啊 ，type 個答案落去啊。
哦，我試下。
係有個 T 字嘅 function 嘅，見唔見到啊 ？Two bar 咧有個 T 字嘅 function 打落去得㗎。
哦，好啊。
好。咁 C part 咧 ，C part 邊個做而家 ？C part
唔係我做嘅。
係啊，寫落去啦，財家。咁啊 A 啦 ，A 頭先咪李達星寫緊啦，寫埋啦。 A part 應該係咪做完啦？我哋睇睇 A part 先啦嚇。佢想 distinguish calcium chloride solution and zinc chloride solution。OK， calcium chloride solution and zinc chloride solution. Okay, so the answer. Now take a look on students' work. Add dilute ammonia solution each sample solution dropwise. The ones which I'll give what precipitate is zinc chloride solution, while it has no precipitate is calcium chloride solution. Isn't it calcium hydroxide be formed? Why is there no precipitate? Is that saying?
因為佢冇足夠嗰個 hydroxide ion 啊嘛。
係咩叫唔足夠咧？就係個濃度啊！我哋講緊個濃度。原來佢個濃度夠高咧，至會 form calcium hydroxide solid 嘅。咁呢度咧唔夠啊 ，not high enough. Concentration not high enough. But which means that if I change the answer anyway, the answer is wrong. Okay, but you have to twist a little bit. Even though you use sodium hydroxide, yeah, you can make the answer to become correct. How? You need to write it
一個
as
dissolve， 一個唔 dissolve 咯。
又係冇分嘅喎，你就聲有個執字眼啊嘛。咩叫 dissolve？ 咩叫唔 dissolve 啊？幾時啊
excess
in excess 嗰陣時候。
係 what in excess？ 就
NaOH
yes
NaOH
added in excess， 明唔明白？咁所以咧呢一度咧好得意嘅呢條題目，好多答法嘅。第一種答法就係咩咧？如果 ammonia 咧就咁答啦。如果你唔寫 ammonia， 你寫 NaOH 嘅話咧嘅答案咧就係所有 both will form the white precipitate initially. Okay, but the PPT we have got that two remains. Now when added, but when NaOH added in excess, the PPT remains and PPT redissolves. We have got two scenarios, right? So the one which remains it is the calcium ion containing, while the other one is the zinc ions containing. While the equation, you need to write down the equation having the formation of tetramine zinc ions, okay, which is a colorless complex. Is that clear? Do you understand? Now, how about the second ones? Yeah, no such black. How about the third one? Add a few drops of dilute sodium hydroxide to each of the test tube, and you are going to a solution, right? So you solution. So we may have got a iron 2 sulfate solution versus iron 3 sulfate solution. So you add NaOH solution to it, dilute sodium hydroxide solution to it, and you look for the formation of the two type of PPT. The first one, please describe it as dirty green. Dirty green precipitate. The other one is reddish brown precipitate. So you know it is from iron 2 containing for dirty green precipitate is formed, while the iron 3 containing, which is the reddish brown PPT, will be formed. So why? Because of the equation. Now you need to write down the equation for the formation of iron 2 and iron 3 hydroxide respectively. Can you get the point? Okay, how about B part? How about B part? Solid sodium chloride and solid sodium carbonate. OK， 等，回落，等。Now, if somebody write you want to test for the chloride ion, right? It seems when Long's writing refer to distinguish in terms of chloride ion, right? They want to test for the presence of chloride ion or absence of it. So add a few drops of acidified silver nitrate to samples. The ones that give a white PPT. It is sodium carbonate, sodium chloride. How about carbonate? What happens to the carbonate? The observation for it. What is the observation for carbonate? Now take a look on this, a very tricky one. So you may have a sodium chloride solid and sodium carbonate solid. So you look for white PPT. So the sample here, it is solid. It's solid. So something nasty. No. Remember, you omit the first step. The samples into the distilled water separately. Please dissolve the sample into distilled water separately before you do such, okay? So, and afterwards, you are going to add the sample solution and check for PPT. The equation can tell you what happened. So the ionic equation is this: the silver ion react with chloride and to form silver chloride. Can you get a point? So you are going, if you want to have a precipitation reaction, you are going to get a mixing of the two solutions in order to make it happen. Okay, so for sodium chloride and solid sodium carbonate, you need to dissolve in the water first. You use distilled water to get rid of other impurity that may affect the results. And second, it's about the Na2CO3, no PPT, that is correct. But indeed, there is observation. Do you know? There is a reaction. Why? There is effervescence.
因為佢係 exit 喺入面，用嘅 silver nitrate 入面。
Yeah, that's right. So in order to make it more simple, that is also possible, right? You use silver nitrate test is possible. We've got alternative. The second method, another method, is still very simple. We've got two solid here. I add a few drops of dilute HCl into the two of the samples, solid sample respectively. One of them simply dissolve. One of them, they will show colorless gas bubbles. You know that colorless gas bubbles, or that is carbonate. While the one is simply dissolved is sodium chloride. So can you get a point? Can you get the whole logic for doing that type of experiment? Please choose the one which is most convenient to you, because the word distinguish. The key to do that test for distinguishing is that you have to do it in a speedy manner. Fast, efficient, no ambiguity, you can get the answer. Please choose that method. Can you get a point? So tell me your marks. 0 to 10. You find it easy, difficult, or what? For the whole thing. Now, somebody may find it difficult at the later part, right? Especially the later part that requires you to memorize all those equations. Now, this is what I would like to remind all of you. Now, before you do such, now you get to know the properties well. The best way is to memorize it. It's time to try to take some notes on that. Okay, is that clear? And before we stop it here, remind you, today we have got a quiz. We start on 2. We will resume the mocap quiz. Okay, see you guys. Bye-bye.
Yeah.